Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a rational inequality. The given inequality is x minus 2 times x plus 1 square over x minus 4 times x plus 5 greater than or equal to 0. In this inequality, the numerator expression is in factored form, the denominator expression is in factored form, and there is a 0 on the other side of the inequality. The first step is to find the x-intercepts and vertical asymptotes for this rational function. Let's start with the x-intercept. We should set the numerator expressions equal to 0 and solve for x. Let's start with x minus 2. I get x equals 2. We can write this x-intercept as an ordered pair as 2, 0. Next, we can set x plus 1 equal to 0 and solve for x. I get x equals negative 1. This x-intercept can be written as an ordered pair as negative 1, 0. Now we can find the vertical asymptotes. We should set the denominator expressions equal to 0 and solve for x. The first vertical asymptote is x equals 4. The second vertical asymptote is x equals negative 5. Now we can use the number line method. We should draw a number line and show the values for intercepts and vertical asymptotes. There is a vertical asymptote at negative 5 and 4. These four numbers divide the number line into 5 parts or intervals. We have to find in which of these intervals does the given inequality hold true. We have to use a test value in each interval. On the left side of negative 5, we can use the test value negative 6. Between negative 5 and negative 1, we can use the test value negative 2. Between negative 1 and 2, we can use the test value 0. Between 2 and 4, we can use the test value 3. And to the right side of 4, we can use the test value 5. We do not have to do the check for x equals negative 5 and 4 because the rational expression will become undefined at these two x values. However, we should do the check for x equals negative 1 and 2 because the x values negative 1 and 2 will be part of the solution for this given inequality because we have to find the x values where the rational expression is greater than or equal to 0, and at x equals negative 1 and 2 the expression will be equal to 0. So we already know we have to include negative 1 and 2 in our solution. Now we can start the check. Let's start by subbing in x as negative 6 in the given rational expression and see if the expression value is greater than or equal to 0. In the numerator, negative 5 square is equivalent to a positive value. Negative 8 times a positive value will give us a negative result. And in the denominator, negative 10 times negative 1 will give us a positive value. So the overall value will be negative. That means on the left side of negative 5, the inequality does not hold true because the rational expression has a negative value. Next, we can do the check for x equals negative 2. In the numerator, negative 1 square is equal to plus 1. Negative 4 times positive 1 gives us a negative result. In the denominator, negative 6 times 3 gives us a negative result. So the overall value will be a positive value. Therefore, the inequality is satisfied in the interval between negative 5 and negative 1. Now we can do the check for x equals 0. One square is equal to 1. Negative 2 times 1 gives us a negative result. In the denominator, negative 4 times 5 gives us a negative result. So the overall value will be positive. Therefore, the inequality is satisfied in the interval between negative 1 and 2. Next, we can do the check for 3. In the numerator, 4 square is equal to 16. 1 times 16 gives us a positive result. In the denominator, negative 1 times 8 gives us a negative result. So the overall value is negative. Therefore, the inequality is not satisfied in the interval from 2 to 4. Next, we can do the check for x equals 5. 6 square is equal to 36. 3 times 36 gives us a positive result. In the denominator, 1 times 10 gives us a positive result. So the overall value will be positive. Therefore, the inequality is satisfied on the interval to the right side of 4. As per the analysis, the inequality is satisfied in the interval from -5 to -1, including -1, and it is also satisfied in the interval from -1 to 2, including -1 and 2. Since these two intervals are adjacent intervals, we can combine these two intervals into one big interval. The interval will be from -5 to +2. We can write the solution in inequality notation as we cannot include -5 in our solution because there is a vertical asymptote at -5. So this is the final answer in inequality notation. We can write this solution in interval notation as this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.